G'day and welcome to another Visions of Chaos tutorial. This tutorial is all about simulating video feedback. I'll be showing examples of physical video feedback and then demonstrating how the video feedback simulation mode works in Visions of Chaos. You will see how I created the video feedback simulation that is currently playing. So let's get started. Firstly, let's start with real physical video feedback. The process is relatively simple. You take a camera and film the monitor showing the camera's output. This creates a feedback loop which leads to the interesting and unique visuals. If you want to try real video feedback, I have some tips on this webpage of mine which I'll link to in the description. For a real world example, let's take a look at this example movie from James Crutchfield back in 1984. You can watch this video in full later if you wish to, but let's take a quick look at some of the example results. I also have a few other video feedback examples linked to on my video feedback page. You can also search for video feedback on YouTube to see other examples. Those videos show the basic structures of video feedback and what Visions of Chaos has tried to emulate over the years. Okay, now let's see how to use the video feedback simulation modes within Visions of Chaos. Visions of Chaos has 3 different video feedback modes. They all use the same basic principles of simulating video feedback by repeatedly applying image processing techniques to an image. For this tutorial, I'll be using the Video Feedback 3 mode as it has the most options and features for creating unique images. This tutorial will be more of a hands-on demo explaining each setting in more detail. At the end of this tutorial, we will have created the simulation movie shown in the intro of this tutorial. Let's get started. To start off, I'm just going to load the default video feedback file just so we get a rough set of settings here to play with. The first thing I'm going to do is click clear, which removes all of the effects from this list. This means that during the simulation, no effects are being performed on each frame. The starting configuration determines what picture or image kicks off the simulation. You can specify a specific image file, a single pixel, or random noise. I normally just use the random noise. Without any other effects, if we just use the random noise, so that shows the random RGB noise that starts off the video feedback simulations. Okay, let's try and add an effect in now. First, we'll try stretch, which is a zoom of the current picture. This zoom factor here determines how quickly it zooms in. A zoom factor of 6 means that each of the 4 sides will zoom out 3 pixels, and so the overall image size grows by 6 pixels in width and height and is then recentered onto the image. So if we have a look at a zoom speed of 6, that's all that happens, nothing too exciting. There are also a variety of zoom algorithms to play with. Nearest and draft tend to be very square, basic zooms, whereas as you go down the list, they are more based on curves and result in more plasma-like zooms. So one of the problems with doing a repeated zoom is your overall brightness fades out to black. Now, a fix for this is the histogram effect, histogram equalize frames, and that does an auto brightness, so it makes sure that frames don't get too dark and they don't get too light. So if we add histogram to the order of effects and click that again, we now see it maintains a even balanced brightness as the simulation runs. Now, you will also notice that with this particular zoom method, you can see a horizontal and vertical break in the zoom, and in some of the zoom methods, this is a lot more pronounced. One way to avoid that, I found, is that if you use the Mitchell zoom algorithm, that helps hide those lines, and so now there's no hint of that the vertical and horizontal axes. So now just using those two effects has given us a nice zoom into a cloudy type display. Okay, let's try some other effects. Next up, I'll cover the Perlin noise, or the Perlin noise flow. Perlin noise is used to generate textures similar to these pictures here. You can have a detailed Perlin noise or more smoother Perlin noises, as these other pictures show. Perlin flow takes the current image pixels and moves them according to a Perlin image. If you imagine this is a 3D height field that has the white pixels at the peaks of mountains and the black the valleys of troughs, the image pixels will flow down the slopes, and so following these slopes allows the image to be moved in various ways. So if we turn on Perlin flow and add it to the order of effects, and now we run the simulation again, you see the picture is stretched and distorted according to the underlying Perlin noise. Changing the octaves to a larger amount has the effect of smoothing out the noise, and so the more octaves you use, the more smooth like this or even this the noise will be. So if I put that up to 14 now, you will notice that it's not as busy in movement, and the Perlin features themselves are much more larger. So if we go about halfway, you can also drop the flow length right down as well, so that's not as noticeable. And so if we go for an 0.5 there and 12, then it's a much more subtle movement and not so extreme. We can even go lower if we want. Take that right down to 0.1, and you can hardly tell it's occurring now. So that's a Perlin noise flow. Let's cover bloom now. What bloom does is it takes pixels with brightness above a threshold and it blurs them out and then blends that with the last frame. So this has the effect of really bright spots get more brightness bleed into the surrounding. If we just do a threshold of 200, because this has a fairly bright result already, you'll see that the bright pixels get brighter and it just spreads out. The threshold can be changed, and so if we want only the brightest pixels, we can go up to, say, 245, because the brightest is 255, the lowest is 0. So if we take a threshold of 245, only the brightest pixels then bloom, which gives us a different result. You can also increase the blur radius. Let's try 225. And so then the bloom spreads a lot wider. So that covers the bloom and how that can add effects into your simulations. Now let's have a look at the blend effect. What blend does is it takes each frame and it blends it with the previous frame. This is more in line with the real video feedback, as the real camera and monitor pictures get more blended in with each other as they're going around the loop. So if we take the default blend mode of averaging, that then gives us this much more video feedback like smearing of the image as it zooms in. If you have a look at the blend mode drop down, there are all these various types of blending. If you've ever used Photoshop or some other image processing program which has got layers, you've most likely seen these names before because they all use a standard algorithm. Here's some pictures that give you the basics results of how they work: dissolve, darken, multiply, color burn, etc. So as you use those within the video feedback simulation mode, they will all give you unique results. Some of them may cause the simulation to die out like that. Others may turn it into a whiteout. Others will cause static flickering. So you can try those and see how they affect your simulation. For now, I'll just stick with the average. Okay, the next effect we will look at is the HSL flow. HSL flow makes pixels move around the screen based on their colors. How this works is the individual pixels' RGB values, the red, green and blue, are converted into HSL values, which is hue, saturation and lightness. And then these HSL values can be used within these formulas to move the pixels around the screen. Once the RGB are converted into HSL, the HSL values are between 0 and 1. So for this angle formula, depending on the hue of the pixel, determines which angle between 0 and 360 degrees that pixel will flow into. So a pixel's hue determines where on this color wheel its color is closest to. So with our formula, using the hue times 360, depending on the pixel color, determines which angle that pixel will flow into. So that gives us an angle for each pixel to flow in, and next is the length formula, which determines how far the pixels move. The saturation of a color is how intense and how pure that color is. So this takes the saturation value, multiplies it by 5, and gives us a length. So a pixel that's very bright red, for example, will be moved further than a pixel that's black or just white. So if we just take these two formulas now and have a look, so here the black and white pixels aren't being moved too much, but we'll notice that as these colors start to come in, you will see that they are getting smeared and moved, and so that's happening because of this HSL pixel flow. That can give you some really unique, almost fluid-like flow in some cases. And these formulas can be changed. Like, let's say we want to also take into account the lightness value, which is how bright a pixel is. We will have turning based on both the hue and lightness now. And so that gives us even more unique results. Maybe not basing the length on the saturation. What if we try basing that on the lightness? And so brighter pixels will move further than the dark ones. And if we set that to times 3, and so the maximum will only move 3 pixels instead of 5. It gives us a whole new result. Let's try hue there as well. So we'll base the length on the hue now. Okay, so that's killed off all the color. Try some saturation there. Now, This is now fairly flat and plain. So one way to get some more detail in there is to add noise to the simulation. And noise just adds a bit of randomness to each pixel's RGB values as a percentage. So if we just put in 5% noise there and restart, you see we get a much more rough pixelated effect now. Just want to go back and play with these a few times, see if we can get something a bit more. Let's try the angle based on the lightness. Now, one way to help more color come out is if we use some contrast. It doesn't take much. You can just use a 5% contrast. No, in this case it doesn't seem to like it. What about 50? Okay, that's too much. So let's try 15. This really isn't doing it for me. Let's go back to hue and hue for length. Remove the contrast. So now the colors are coming back, and that's what I want for our resulting demo movie. So for now, I will leave those HSL formulas as is, except that you can play with those as much as you like. You can use any standard mathematical formulas in here using HSL values. Okay, so the next thing is to do a blur. So you have your blur strength here. 1 is lowest, go up higher, obviously we'll blur it out more. Blur just helps to smooth out noise values. Let's put a bit of that contrast back in. So with just a smidgen of contrast, it really helps get these primary colors to start to pop out more. Now here, since that length formula is based on the saturation, you will notice that as this zooms in, the color areas flow more rather than the white sections which don't. Try and increase that zoom a bit, get it moving a little bit quicker. Okay, another effect to play with is the sharpen. And so sharpen is just like any image processing sharpen algorithm. If you do a sharpen after a blur, because the blur and sharpen use different algorithms, they don't cancel each other out. And the blur followed by a sharpen usually leads to nice video feedback like fingering patterns. So that has now given us these much more video feedback like little stripes. If we turn off the pixel flow to just see the actual effect of that, see we get these much more almost reaction diffusion like patterns. So we'll turn the flow back on. Maybe for that we should increase the blur, bump the sharpening strength up. Okay, so that's giving us a variety of colours there. They are a bit too primary for my liking. I'd like some different colours in there if possible. Let's try just reducing the contrast a notch. Okay, that shows potential. There's some different colouring in there. What if we just kill contrast, put it to 0 for a sec, which is the same as disabling it out of this list here. Okay, the colours are still coming through without it, so let's remove contrast. There is also a colour effect, which you can change the amount of colour in the image. So the 100 is just as is. So if we try that to 105, see that can really bring out more colour. 105 is just a slight tweak, except because it's being fed back through the process frame after frame, a slight change can really change the result. So even if we do just 101%, okay, maybe try increase this sharpening even a little, or maybe we can put the blur back down now. Let's try that to 3. I don't want it so high detailed fingering, but I don't want it so... Yeah, that's kind of nice, about that level. So I think the colour setting is pushing the greens and the magentas too far and washing out the other colours. What if we even try just a 99, and so it's actually reducing the colour each frame? This can sometimes help. You'll still have colour there, but it won't be as intense. But here it just seems to have killed it altogether. So let's have a look. What else haven't we done covered yet? Okay, brightness is obviously the brightness of the display. Since you've got histogram that also comes into play, say I put this up to 110, rather than making the whole image white, the histogram kicks in and pulls it back, and so that can lead to unique results as well. A lot of colour there now. Let's try interlacing. Now what interlacing does is for every second frame it renders even and odd lines. So it kind of simulates how the old television transmissions were, how they'd only send every second line per frame. And so one frame it renders the even lines and the next frame it renders the odd lines. So this does that same effect. And this can lead to new unique effects as well. It's worth trying on or off. Try a little bit more noise. Okay. Now, the next setting we'll have a look at is mirroring, which is fairly self-explanatory. You can mirror the left side onto the right side, which gives you a mirrored image. And you can also mirror the top to bottom. Both of these have also got the other way if you prefer to whichever suits your current simulation. So that gives us a nice four-way symmetry there. Now in this case that colour is a bit intense. Let's try the colour again. Maybe just 99% will pull it back a little bit. I want colour, but I don't want those full-on intense solid magenta colours. A little bit more. Let's try 95. Right, so 50 is too much. That just makes it grayscale. I think also that brightness is a problem. Let's remove that because the whites are bleeding out. So that's getting us back to more subtle colours. I think that blur is taking over, so if we up the sharpening now, you can see how it's a real delicate balancing act sometimes of trying to adjust the various settings, because to me this is a little bit too detailed, whereas I'd like this fingering to be a bit more wider. But since I can only blur in increments of 1 with the current formula I use, I can't do a 1.5 blur, which would probably help in this case. Note to self. Okay, but this isn't too bad. Let's just try bumping that up again and that. That's a bit more like it. More colours, not too much detail, but not too much blur. That's kind of in the area I'd like. Now let's try adding some rotation into it. Just do 0.5. Rotation, as the name implies, rotates each frame by this amount of degrees. Now since it's being mirrored, you get this different effect of it coming out of the sides and moving up to the top. I think it'll look better if it came out of the top and down, so we'll just do that with a minus degree. Actually bump that down to maybe 0.3. Okay. Again, let's play with some other settings. Maybe contrast, but that might just blow out the colour too much. We'll see. You can also change the order of these effects around. I'm going to try and move the noise around because there's not enough noise coming through possibly. So what if I do that after the blur and sharpen instead of before the blur? So in that way, that noise can feed through a lot of the other effects before it's blurred again in the next pass. So here, as these shapes are spreading out now, they've got more of a noisy, static effect to them. Let's have a look at the matrix coloring. Now, the matrix coloring, as it says up here, is a display-only filter. And so that means no matter what your current video feedback simulation is doing in the background, when you click on the Use Matrix Coloring, it takes each of the pixels' RGB values, it multiplies them using matrix maths, and it gets a new RGB value. If you've got ones on the diagonal and the other values 0, this is called an identity matrix, and it basically just copies the RGB values. But if you change these to random values between -1 and 1, you will get new colors. So you can click random there and it gives you various colors out. This can sometimes be nice if you've got a grayscale simulation and you want to add some color into it. And you can also histogram, equalize, or auto brightness. That can give you a lot more reaction diffusion like fingering type patterns. And hue shift. So as we covered in this hue wheel here, the hue shift will move colors around the wheel. And so if you've got a slight hue shift, yellows will become more orange, oranges become more purple, purples to blue, blue to green, etc. If you have a large change, yellows will shift to purple, reds will shift to green, etc. And so that's controlled by this slider here. So you can do a little bit of a shift and the colors will change. This is helpful if you have a simulation that may have a lot of blue colors, say, and you would rather the blue colors to not be so prevalent. You can then change the hue slider and have it output more yellow colors or more red colors. Like in this case, that's lots of blues and greens. But if we shift that down to here, now it's more of the magentas and cyans. So yeah, so hue shift just allows another set of values to play with. And you can also cycle that every frame, and so if we just click that and run, you will now notice that as the simulation is running, as the colors start to appear, they will cycle through the hue spectrum, and so they go through the rainbow Roy G. Biv. And so that can give you a nice pulsing color effect if you so desire. But we'll just leave that at the default for now. Let's try playing with this a bit. A different zoom algorithm. Let's just turn off the mirroring for now. And just turn off the rotation. That just helps speed while trying various settings. Play with the angle again. Actually, that's sort of nice. So Okay, that one has a lot of colours, which was what I was basically aiming for. Let's turn mirroring back on. Also put the rotation back on. Yeah, I'm starting to like that now. Let's try with a little bit more rotation so it's spreading out from here quicker. Not sure if that's too much now. Okay, I think that's pretty good. I think that'll do as a nice, just a example one that I can put at the start of this tutorial. Let's just save that. So if you've got a future version of Visions of Chaos, you can play with this one yourself as sample 442. One thing I haven't covered is the shuffle button. Now, depending on the order of these effects, it can change the result drastically. And so the shuffle button just randomly shuffles these effects. And so we can see if that helps create a better effect. In this case, it seems like the blur was moved into a spot that it has way too much of an effect. Okay, let's try another one. So with these shuffles, I'm using the shortcut keys to make it simpler to try multiple random runs. With my left hand, I hit F3 to stop, F4 to start the mode, and then since the shuffle button is highlighted, enter with my right hand to start. And so then you can quickly go F3, F4, enter, F3, F4, enter, F3, F4, enter. So that saves you having to go click, click, and moving the mouse around constantly. So that's a faster way of doing multiple random runs if you are like this, looking through various random results to see what happens. The only thing changing here is the order of the effects. The settings for all the contrast, etc. are all kept the same. It's only the order of the effects that gives these unique results. Shuffle can give you a whole another batch of simulations to play with. The video feedback simulation mode has got hundreds of sample files, and so you can also load these, hit shuffle, tweak settings as much as you like. There is also a randomize button which randomizes all the settings, and so you can again try that multiple times and see if anything interesting appears. Most of my sample files were found by this method, repeatedly trying random results. Another option for finding new simulations is the crossbreed button. What the crossbreed does is it takes 3 of the current preset files and it loads random settings from each, and so it basically blends 3 different parameter files. So this tends to give more possibly pleasing results, but of course those randomness can also lead to a mess. If you want to make movie files, just like the other modes, click on Create Movie Frames, and then as the simulation runs, each frame will be saved as a frame file, and once you stop the simulation, you'll be able to combine those into a movie file. So what I'm going to do now is I'm going to take this sample which was built up during this tutorial, and I'm going to render that out, and I'll put that at the start of this tutorial, and so this should have been the first thing you saw when you started this tutorial. So that covers all the various settings in the video feedback mode. I hope this was helpful. It followed a less scripted structure, but I hope it gave you an idea of how to tweak all the settings and to use the video feedback mode in more detail. Let me know if it helped, and let me know if there are other specific features of Visions of Chaos you would like to see a future tutorial on. Thanks for watching.